Hey and a very warm welcome for another episode of Show Off Your CI/CD Pipeline. And today I'm very happy to have Joe with me. Hey Joe, welcome to the show.
Hey, I'm happy to be here. Thanks for inviting me.
Great to have you. So most of the audience will most probably not know you, but we know each other from the Community Builders program, which we are both part of. What is your current day-to-day role? Who are you? Where are you from?
I'm a senior cloud architect. I've been working for SurePrep for a while, and then our company actually just got acquired by Thomson Reuters. And I live in Colorado, just outside Boulder. And I'm very excited about AWS and sort of cloud architecture in general. My role has mostly been about modernizing existing legacy systems. This is actually the second time I've helped modernize a startup acquisition for acquisition, basically. So that's where I'm at.
Cool. So that means from a technology-wise perspective, you're mainly on the microservices world and using Java or something else?
Actually, most of my career has been in Python. And the reason for that is because I work with data scientists a lot. So I work with data scientists and PhD statisticians, and I basically help take their ideas, right, which, they can maybe run one time and then help them run it, tens of millions or hundreds of millions of times in the cloud, because they like to write in Python. And so we tend to do our production code in Python too, which I know is a little bit unusual.
It is not as much as unusual as you think. There's a lot of organizations that use Python today. My team also uses Python at the moment for one of the projects that we are running in production. So it's not as uncommon as it was before. It's not my personal favorite language, to be honest, right? So I grew up with Java, some PHP, and at the moment I'm trying to put some focus on TypeScript as well.
Yeah, so, typing. Yeah. Sorry, continue.
So what are we going to look at today then? It's going to be only Python code, or what do you have for us?
So I think we're going to talk a little bit at a high level about what our CI/CD pipeline looks like, and then we can dig in a little bit further into the individual services that comprise our CI/CD pipeline.
Cool, and we're going to use GitHub Actions, or what are we going to use as a CI/CD tool?
So we start. Well, I actually would like to get into that because that's a really specific focus for us right now, is transitioning from Bitbucket to GitHub. So I'll talk about that a little bit.
Cool. Then let's not waste too much time with an introduction, and let's move over to look at your pipeline, your code, your diagrams that you have prepared. So whenever you're ready, you can start sharing the screen and we can get going.
Sure. All right. Can you see my screen okay? There should just be an empty terminal here.
Yes, looks a little bit black, but should be good enough.
You see this diagram here?
Yes.
All right. So this is at a very high level our entire build pipeline. So a developer comes in and commits code right now to a Bitbucket repo. And the nice part about this particular setup is that it doesn't really matter what the Git hosting provider is. We will be shortly migrating Bitbucket to GitHub Actions because Thomson Reuters acquired us, and Thomson Reuters has a large enterprise account with GitHub. But almost all Git hosting services provide YAML files as sort of their the entry point into their pipelines, and the YAML file actions are all pretty similar, so it's pretty easy to just swap out Git hosting providers in a pipeline like this. So
let me ask a minor question for the
yeah,
audience
sure.
on this, right? So when we talk about Bitbucket in this case, you're not talking about Bitbucket as a Git provider. You're talking about the functionality of Bitbucket pipelines that comes with Bitbucket Cloud, especially. Is that right?
Yes, thank you for that clarification. Yes, we host our Git repositories in Bitbucket, but we also use Bitbucket pipelines, which is the equivalent of GitHub Actions on the GitHub side.
Okay, makes sense.
So, so once a developer on our team commits code into the Git repo, Bitbucket Pipelines has a YAML file that has some instructions. And those instructions in our particular system, our very unique bespoke system, sends a message to an RDS queue in Amazon. So we have a Postgres table in RDS, and that Postgres table is basically a priority queue that we have designed ourselves. And those messages from the build system get sent to that priority queue, and then a deployment row is created, and we have a very lightweight Lambda then that pulls that priority queue in RDS every 10 seconds and just says, are there any builds? Are there any new builds? Are there any new builds? And once some builds get pushed from pipelines to the RDS queue, that Lambda has some evaluation logic that decides, okay, if I have 6 new rows in the build queue, first of all, what are the highest priority builds? And the builds that have the highest priority are generally production builds, right? And then we have different flavors of builds as well. Those flavors being like a Python library that gets pushed to Code Artifact in AWS, or a Docker image that gets deployed out to Lambda associated with an API gateway. So there are lots of different types of builds that we could potentially make, and the Lambda decides which of those builds has the highest priority, and then sends them over. And I guess the next piece that I should emphasize is that some types of builds can be run in parallel, and some types of builds have to be sequential too, right?
Okay.
And that's the other piece that really needs some extra business logic around it. For instance,
so
sorry, go ahead.
Let me just try to summarize what I understood, right? So
yes,
this Lambda function at the end serves as kind of a scheduling or queuing system for your builds, right? The main reason for that being that the builds that are being started can have dependencies or dependent builds that need to be triggered in advance. So the Lambda function will then take care of initiating the actual code build project, which will then do the actual build, right? But it will recognize the order that you require. And this is something that you have built within that Lambda function, right?
Yes, absolutely. And in general, the parallel builds are branch-based, right? If 2 developers are working on separate branches, they will automatically have in our system temporary environments built for them. And this is, I guess I should back up and say that a lot of people test their serverless deployments locally, right? They use something like AWS SAM. They use some kind of framework on their local system that sort of mimics the cloud system, so that they can figure out if their code is going to work up in AWS. We take actually a slightly different tack, which is the code can be unit tested locally, and even an entire scripts can be kind of integration tested locally. But we require a temporary environment to be built in AWS for final testing before we can actually even go to our development environment, because the development environment is used by, so many people. We want to make sure that the development environment doesn't get broken for some silly reason, right? Before code gets pushed to that development environment. So our temporary environments are essentially like an API gateway that gets spun up, a Lambda that gets spun up, some Docker images that get created to be run on the Lambda. Everything that needs to be run in a particular serverless stack gets spun up in a temporary environment that is only used by that developer during development of that feature. And then when we create a pull request and a code review, and all of that code gets committed to the main branch, that temporary environment is destroyed. And so each of those temporary environments can build in parallel. Does that make sense?
It does make total sense. And I think that's a common approach as well. I was recently listening to a talk from Luke Van Gersten or something like that. I can send you the link to the talk later, where he was talking about testing serverless applications, followed exactly the same or similar approach, right? Where you have that level of integration test that sits in between of the real integration tests and the unit tests to start with. A question on the pipeline being triggered here. So this means that this queue message is going to be added for every push that the developer brings into Bitbucket Git, into the Git repository at the end, or will it only trigger for certain aspects of a push?
Yeah. Well, the developer can decide. So there is actually a flag in the code where the developer can say, I would like to create a temporary environment on every push, or they can just set that flag to false while they're getting their code set up at the very initial stages, and they don't necessarily want a new temporary build every single time they push.
Okay, that's then handled by the Lambda function at the end.
Yes, exactly.
Okay, cool. Why are you using CodeBuild here and not a code pipeline as an example? So I understand that there is some business logic that needs to get into the function, right? So you cannot directly trigger the code pipeline. But is the build step so small that it is good enough to use CodeBuild here?
So that's a great question. So a lot of this design is actually caused by our legacy systems, right? We don't necessarily, when we built this entire CI/CD pipeline, we knew that we were going to migrate away from Bitbucket pipelines. And we knew that also we would be staying on AWS. And so basically this design is intended to prevent as much platform-specific logic on the Git host side, basically.
Okay, that makes sense. This means you offloaded some of the stuff already to the AWS environment because you knew that it's going to stay.
Yes. Yeah,
cool.
Exactly. So then a lot of interesting stuff happens in the code build side. We can get into that a little bit more later, but the basic idea here is that we create a deployment image, a Docker image that gets uploaded to ECR, right? And then CDK creates transpiles to CloudFormation, uses that ECR Docker image to deploy out a Lambda. So these are mostly Lambdas, Docker Lambdas that get triggered by API Gateway. So almost all of the code build code is CDK, but there are some additional very specific to our environment deployment steps as well, because one of the things that we have here as well is a manually created JavaScript page that promotes from like dev environment to stage environment to prod environment. But I could talk about that a little bit also. But let me pull up. First of all, do you have any questions about this particular
I think here? No, I asked most of them. I think I'm gonna pause my next question until we are one level down, right?
Okay.
The one that I have is related to where does the CDK code that you just mentioned live, right?
Yes.
I assume in the same repository, but I think you have that most probably in the next piece of slides that you have.
Yeah. Yep. Exactly. So let's go there. So actually, this is what. Pop up the diagram again. Here's that Bitbucket pipeline that we talked about. Here's an example of what a Bitbucket console looks like when it runs the pipelines. There's basically the only logic in the on the Bitbucket side is determining what type of information to send to this RDS priority queue. So depending on, we have a monorepo, first of all, I should say that.
Okay.
And that's why there's some additional logic on the pipeline side to determine, hey, this is this particular feature, trigger a build on this particular feature, etc. So I can then jump into a little bit of the code here. I have a hello world example that basically mirrors exactly what we do in our actual code. So you can see that the structure of this folder is set up with a CDK folder, a source folder, an app handler. People who run Lambdas recognize the name app handler because that's the entry point into the Lambda. You know, a Docker file to build the Docker image. So
that's an interesting thing. Why are you building a Docker container for a Lambda?
We have, so remember earlier in the conversation, I mentioned that we have data scientists working on this code. Lambda has limitations on how big layers can be. And some of the particular operations that we're doing in the Lambdas require such large Python packages that they won't fit in layers, basically.
Okay.
So we're building Docker containers instead that run on Lambda, because you can run up to a 10 gigabyte size Docker container on Lambda, which is much larger than what you can get in Lambda layers.
Okay, cool. Yeah, that answers the question I had. Thanks.
So the other pieces that we have here are very specific to our setup. Each individual API. So just think of this folder as containing everything required to deploy an API gateway Lambda-based API. And this endpoint.py, I can't actually show you any specific code from an endpoint.py.
That makes sense. Yeah.
File just for proprietary reasons, but I do want to say that that this endpoint file inherits from a base class that has some other really fun capabilities that get built in our build pipeline. And one of those capabilities is, let's see.
So at the end, it's going to be kind of the CDK construct that you're using to define the API endpoint for this Lambda function. That's what I'm
absolutely
hearing.
And I should, yeah, actually, that's the next thing I should talk about. This is just a little bit of a sidelight here, which is that all of our build pipelines also build Swagger documentation that gets served along with the endpoint that gets deployed. So if we go back to the code, you see here that this is a hello world endpoint. This hello world endpoint is served from API gateway, but as a sort of sub folder, if you will, in API gateway, we have an openapi.json document that gets served. So hello world /openapi.json that serves the Swagger documentation, and the Swagger documentation is built based on the code, not manually built at any other point. And I know that there are lots of frameworks that do this, right? This is just a little bit custom because of the way that we're using API gateway and Lambda. I'm sure people know that, like, in Flask, there's that like Flask REST Plus that provides Swagger documentation, and there are Java packages that provide that Swagger documentation. This is just like a custom implementation of that, basically.
Okay, cool. So this means you have multiple microservices that have the same kind of structure with a Lambda function and the API endpoint in the background, and all of them are going to be triggering an event in Bitbucket Pipelines, which then pushes to that RDS instance from a CI/CD perspective once you push something to the Bitbucket repository. Now, the main key thing, as far as I understood you, is going to happen on that code build, right? So is this a one code build implementation for all types of microservices here, or is there a difference in the way that you attack different types of builds?
It is a single. So first of all, you encapsulated that beautifully. You said it much better than I initially did. Thank you. In CodeBuild, we use the same code stack to build everything, and that is things like the example that I'm giving here, API gateway to Lambda. It also includes things like queue readers, right? We have CloudWatch events, cron job based queue readers for asynchronous endpoints that write to queues, those get built in the same way. Python packages that get pushed to code artifacts, those get built in the same way. It's just different code paths in CodeBuild.
Okay. So just that's an important point to understand, and I'm not sure if we can look at the CodeBuild code, right? Because from a CI pipeline perspective, what you're saying is that within the CodeBuild step, what you're actually doing is you are, based on an input, choosing which path of the build you're going to execute. But you have chosen to have one central code, one central definition of code build, which then decides on which steps are going to be executed and which steps are not going to be executed. Is that understanding correct?
Yes, absolutely. And honestly, that is a 1,500 line script that has lots and lots of different paths, but at the simplest level, what that deployment code does that gets run on CodeBuild is it goes to the folder that we're trying to build. It opens up the CDK directory, because there's always a CDK directory in every single directory that we build with CodeBuild. And because we keep the infrastructure as code along with the application code, just like this in every single location, right? There's a CDK directory for Hello World. You can see for some of these other endpoints, there's a CDK directory, there's a CDK directory. They all are built the same way. And then,
but they are not all creating different API gateways, right? You're reusing an existing gateway and importing it, I would assume.
That's a great segue. Let's look at the bottom of this API stack and see how that works. So because this is CDK code, right? We say, so we use the CDK import value functionality that allows us to cache information from previous stacks about our API gateway ID and our root resource ID. These are the two things that you need in a CDK stack to regenerate a Lambda REST API, right? You can say from REST API attributes, here's the REST API ID, here's the root resource ID, and we get those from this caching functionality in CDK. So yes, there are some complications here in the CodeBuild code with respect to how do we determine if there's an API gateway already up? Because if you're in a temporary environment, maybe you don't even have an API gateway up, and so you have to do multiple CDK stacks, right? Build the API gateway, then build the Lambda that talks to that API gateway. And then a big complaint of mine, you have to actually set up a new CDK stack for stage deployment in API gateway, because if you're running a Docker Lambda that's attached to API gateway, when you redeploy the Lambda, the API gateway doesn't necessarily, or doesn't recognize that it should do a new stage deployment. So you have to force it to do a new stage deployment. And this is actually something I've talked to AWS engineers about, and hopefully it will be changed in the near future. But the point is, multiple CDK stacks could be deployed at any given time.
Okay, makes sense. I'm going to be poking another time on the code build structure. Why did you decide to have that one build step only and not differentiate between multiple build steps that you could then tie together in a code pipeline or something like that? So what you're explaining is like, I have 1,500 lines of code to define which build steps to use. right?
Mhm.
Now, there are different possibilities that I could think of on how to orchestrate these kind of build things. Code pipeline being one of them, step function being another option. But you have chosen to have that code within CodeBuild. There must have been a reason for that. Do you know or remember what the reason was?
Yes. So one of the other things that one of the other things that's important to us is the ability to version appropriately and roll back appropriately, right? And there are in every CI/CD pipeline software, Jenkins or yeah, whatever CI/CD software you choose to use off the shelf, there is this ability to roll back, right? Code, but because some of our environments are so specific, like the way that they're built is so specific, what we wanted to do is build our own versioning system. And so we actually have some other RDS tables that track like far more versioning information than we could get with sort of an off-the-shelf product. And the other thing that we wanted to do was build our own internal code promotion dashboard. And I wish I could show you that actually right now, but that is one thing that
and that's
I'm
totally
not allowed to show you.
That's totally fine, and that's what. But the main thing here is that this is a common problem that not only you have, right, but that also other organizations have. How do I make sure that I can visualize in which state is my current environment or my current change, right? So different viewpoints. On one side, I as a developer want to see where is my code? Is it already in production or is it still in pre-production? On the other side, in an incident, I want to directly glance what the current status of the environment is where I have an incident, right? And I think there's not really enough support to visualize these kind of things today. At least that's my personal feeling. So I understand that you need to build something homegrown because I've built more than one similar thing in my career.
Yeah, absolutely. It is kind of incredible once you start building CI/CD pipelines, how often you think to yourself, I actually want to build a custom thing here instead of using the off-the-shelf thing. So yeah, I don't want to belabor this point too much, but the rest of this stuff is all. One piece that I do want to emphasize is that we actually do Docker and Docker for these builds, mainly so that we can set up. I can show you. Oh no, this is actually not very useful. It uses a base image that we built ourselves that contains all of. It contains npm and everything that you need to run CDK, so that whenever we basically can use this CDK builder image to build any place that runs Docker instead of having to install all of those like CDK dependencies and everything like that. Yeah. So that's why that Docker file is there.
Yeah, okay, that makes sense. So it's a baseline image that you're going to use with all of the tooling that you actually need to then execute your deployment. Okay, Joe, thanks a lot. Do we have anything else you wanted to touch on? Otherwise, we could be wrapping up. And I think I lost you. Go. So as you can see, the lights are a little bit darker now on my side. We had a little bit of an internet outage, so we needed to pause the recording, which is something that I usually try not to do. But now we're back to do the recording with Joe. So Joe, as a wrap up, what do you think is the most important piece of the pipeline that and the CI/CD strategy that you have presented to us today?
Yes. Definitely. I mean, this might be a little bit of a cop out, but certainly the fact that CDK has a Python flavor is the biggest deal for me personally, because our team writes all their code in Python, right? The data scientists only know Python, and the ability to allow them to change the infrastructure as code templates without touching any other parts of the system or learning a domain-specific language or something like that is very important.
Cool. And what are the next 1, 2, 3 things that you think you need to do to get better at CI/CD with your current project and setup?
For us, the system itself is solid and working, but we have some very business-specific use cases that we need to make improvements for, things around research environments and making sure that we treat data appropriately, right? Right now, all of our data scientists have access to all the data, and there's certain aspects of research that need more sensitive data. So
okay,
that's
so that is more than on the application side. How do we make restrictions on the data permissions and data access, right? It's not directly on the pipeline or on the CI/CD strategy, the way that I see it, right?
That is true. That is true. The only place where that really overlaps is when it comes to the development piece, right? Because we do run our pipeline code for temporary environments and sort of in research applications as well. People deploy out these pipelines to a research environment so that they can test before they even go to dev stage prod. And so it's just something we have to be aware of in CI/CD, not necessarily like a part of the CI/CD pipeline. You're right.
Cool, awesome. And then, kind of last question: where can people find you online or ask additional questions that that they might have for you?
Yeah, sure. I'm on dev.to. I've been blogging for AWS Community Builders on there. And then I'm on Twitter at Joe_Stech. If anybody wants to reach out there, I'm always happy to engage.
Cool. Then let's add those links then later to the video when we upload it. And then last but not least, what would you like to get out of the audience after this call? So do you expect any inputs or any remarks from any listener, right, that maybe could help you to move and to progress better?
Yeah, I mean, I guess the main thing would be if any pieces of the pipeline that I've presented seem like they could be accomplished in an easier way, I'm always open to constructive criticism. So reach out.
Cool. And this is not open source, so we cannot link to the code, right? So if you fancy to see some more details around the pipelines, or maybe even some details on the build specs, Joe will definitely also be able to help with some guidance here. So thank you so much for taking the time to do this recording with me, and looking forward to bring this up on the YouTube channel and then see what feedback we get from the community. And then I also hope that I'm going to be able to get you to support me on the project to have one central repository that has multiple implementations of the same pipeline. So that's going to be another thing that I'm planning to do later this year. Thank you so much.
Great. Yeah. It was a pleasure talking with you, Johannes.
Same. I had a lot of fun, and sorry for the hiccup with the internet, right? But I'm glad that we finished this today, and yeah, looking forward for other collaborations that we might do in the future, Joe. Thanks a lot.
Thanks. Bye.